Welcome to Minimal Impact Design Standards MIDS Calculator Module 13, Rainwater and Stormwater Harvest and Use Reuse. To see other modules, you can go to these links shown on the right here in the Minnesota Stormwater Manual or in your browser. In this module, we're going to quickly look at some guidance and resources in the Stormwater Manual. We'll then open up the MIDS calculator and look at the harvest and use, reuse best management practice. We'll consider two scenarios, one with a tank, storage tank, and another with a pond being used for storage. And then we'll show you how to get back into the Minnesota Stormwater Manual from the calculator. So the first thing I'm going to do here is I'm going to exit out of here. And I'll just quickly go to the Minnesota Stormwater Manual. You can get there quickly, do a search. Should come up in a Google search or whatever search engine you're using. And if you go to the Minnesota Stormwater Manual, you'll come to a table, the main page or a table of contents, which I'll click on. And if you scroll down on the page, you'll see under Models, Calculations, Methodologies, Fluid Removal, Credits, you'll see a link to the information on Minimal Impact Design Standards. You go to that page and there's lots of information on MIDS, and there's a whole section on the MIDS calculator itself, including how to download the calculator, different user's guide, and some other guidance that we'll get to later, including sample exercises. So let's get into the calculator. You click on the calculator icon shown here, double click, open it up. I'm going to maximize the screen to get rid of the background. And I'm going to open or create a new file under the file menu here. And let's just call it Harvest. Save it. And the main screen on the calculator should open up. Now there are three items you need to enter into the screen in order to get into the schematic scheme where we can work with the best management practices. First is you have to answer this question: are you using the calculator to determine compliance with a construction stormwater permit? We will say no for now. The zip code, I'm going to enter 55155, that's where we're at. That'll populate the rainfall data here. So the rainfall data will populate when you type in the zip code for your site. And then you have to enter some impervious surface. Without impervious surface, you don't need to do any volume control, which is the goal of this effort. And so for now, for the first scenario, which I'm going to consider a storage tank, I'm going to have a 1 acre of impervious. And I'm going to have 3 acres of turf, managed turf on these soils. Now I can fill in this other information if I want, but that's optional. Also, I could change the default retention requirement or phosphorus or TSS event mean concentrations. These are the defaults, but they can be changed. You get a little flag telling you they've been changed, but it's fine to do that. I'm going to go ahead and go into the schematic tab on the top here. And you'll see that on the left toolbar now, this is kind of an accounting toolbar, that it shows impervious acres that are not being routed, as well as your performance goal. We haven't done anything with BMP yet, so we haven't made any progress towards meeting our goals. I'm going to click on the Harvest and Reuse Best Management Practice shown here. I'm going to drag it onto my screen, and it'll appear there. You can either right-click and open it or double-click. I'm going to double-click, and the Harvest and Reuse Cistern Best Management Practice will open. And so here you can route it to another BMP if you want, and you can enter the acreages here. I'm only working with one BMP in this example, so I'm going to have my 3 acres of turf on B soil, and my 1 acre of impervious is going to be routed to this practice. I'll then go to my BMP Parameters tab, which is where I enter the information for this best management practice. So for this example, I'm going to have a 50,000 gallon tank, but you'll notice that the units are in cubic feet. So I'm going to enter 6,685 cubic feet for my storage area. I'm going to be applying this to that 3 acres of turf. For now, I am not going to, is asked to provide a weekly irrigation rate. I'm going to say no. And I'll explain a little bit more about that in a second here. My soil is a B soil. Vegetation is turf. You see that there's multiple options here. And it's going to ask for your starting and ending month. There's a little bug in the calculator here. So it's best to enter the ending month first. You may get an error message otherwise if you try to enter the starting month first. But I'm going to end my irrigation in September, and I'll go back and I'll start it in April. And does the system go offline during the off-season? The answer is yes. This is a tank. Typically, those are going to be drained in the wintertime so that they don't freeze. That's not always true, but most of the time, and especially for outdoor systems, it will be true. And are we going to retain a weekly water volume for non-irrigation uses? And we're going to say no for now. And you'll see when I do that, then I click on a cell that these cells populate, and it tells me that I've actually oversized my tank. So I could achieve a volume reduction of over 5,000 cubic feet, and I only need to get 3993. So I'm going to go back and resize this. So you can use a calculator to actually help you size a practice. And so I'm going to go back and resize this to a 30,000 gallon tank, which would be 4,000 cubic feet. And now you see I'm meeting my performance goal. You'll note that I did not enter a maximum weekly irrigation rate, and yet there is an irrigation rate being applied. That's because behind in the calculator, there's a default calculation being made based on potential evapotranspiration. So if I say no here, I can't exceed the potential evapotranspiration for my weekly irrigation rate. So I'm going to go back now and change this answer to yes. I am going to apply a weekly maximum irrigation rate. And you'll see if I put 1 inch in per week, it doesn't change the volume reduction capacity of the BMP. You'll see that my average irrigation rate went down a bit. That's because potential evapotranspiration rates are less than 1 inch per week in the shoulder months like April and early May and September. But if I was to decrease my application rate to say 1/2 inch a week, you'll see that in fact now I am no longer achieving my treatment volume because I've limited my application rate to 1/2 inch. Based on potential evapotranspiration, I could get more, but I'm restricting that and preventing the calculator from doing that. So I'm going to go back and enter 1 inch per week here. But let's just say now this is a ball field and we want to put a building on here. And that building is going to take up 3/10 of an acre. So now I've only got 2.7 acres to irrigate. And you'll see that I'm not quite achieving my performance goal now. Well, we put a building on there, and that building is going to be active. And we want to use stormwater runoff for, say, toilet flushing. So we can go to this question here, is water being retained for non-irrigation uses? And we'll change that answer now to yes. And it's going to ask me, well, how many cubic feet per week am I retaining? And let's just say I'm going to retain, I assume maybe 100 gallons per day throughout this period of time. And that ends up being 94 cubic feet per week. And you'll see that I'm still just a little bit shy of my performance goal, but I'm pretty close. So I could go back at this point and tweak my irrigation rate a little bit if I wanted to, or I could increase my indoor water use if that was possible. But you can see that there are a couple functions in here that allow you some flexibility in determining how much water you're going to use and what you're going to use it for. I can go to the BMP summary here, which summarizes the information I'm achieving for this particular system. I'm achieving 98% of my performance goal, and only 44% of my annual runoff volume is being treated. That's through infiltration. And one of the reasons that this number is low is because we're only achieving the performance goal during the months from April through September. And that's one of the things to keep in mind with an irrigation system. So you may be achieving your performance goal during the times it's in operation for a harvest and use system, but when it's not being used, you're not achieving your performance goal. You're not achieving any volume reduction. So I'm going to click OK here. I'm going to delete this BMP. I can right-click on it, delete it. It asks me if I want to make sure I want to do that. I'm going to say yes. And now I'm going to go through a scenario where we have a pond for storage. So I'm going to go back to my Site Information tab and change the inputs here. I'm going to have 5 acres of impervious surface, and I'm going to have 10 acres of pervious surface, open space, or forest. So I'm going to be routing my irrigation water into an open space or a forested area. So I'll go to my schematic tab here. I'm leaving my other information the same on that main screen. So now I'll create a new practice. In this case, I'll right-click instead of double-clicking to get to the BMP properties, and you can see that the same image shows up. So here I've just got one BMP again. So I'm going to have 5 acres of impervious and 10 acres of forest or open space. I go into the BMP parameters tab, and here's where I enter the same information as before. One of the things you'll note about a pond scenario is that typically a pond is not going to be volume restricted. Even a half-acre pond, for example, that has only 1 foot of storage, it's going to have about 23,000 cubic feet of available storage, which is considerably larger than the storage tanks scenario that we had just considered. There are times when the pond may not have sufficient water during periods of drought, for example, or if you make your pond fairly small, design it small. But I'm going to enter a value of 25,000 cubic feet for a pond here, and I'm going to be applying it to the full 10 acres. I am going to specify a weekly irrigation rate, and I'm going to have that at 1 inch per week. I actually meant to put this on A soils, so I'm going to type in A soils here. I can go back to my main page and correct that, although it doesn't really affect my calculations. I'll explain that a little bit more in a second here. But again, my type of vegetation here now is I'm going to go to trees. My irrigation ending month is what I'm going to put in first. I'm going to do September. Starting month is going to be April. The system go offline. In this case, the answer is no. The pond does not go offline in the winter. And I'm going to use everything for irrigation. I'm not going to have any water used for non-irrigation purposes. And you can see that I'm short of my performance goal here. If you look at the data, we're getting about 15,500 cubic feet. We need to get close to 20,000 cubic feet. Well, one of the features here is that for A soils and only A soils, we allow a higher irrigation rate. So if I went in and typed an irrigation rate of 1.4 inches, you'll now see that I am in fact achieving my performance goal. And I could maybe even achieve it with a slightly lower irrigation rate. We don't allow this on B, C, or D soil. So if I was to change my B soil, change to a B soil, you would see the volume decrease because we don't allow you to apply more than the potential evapotranspiration demand. The thought here is that on A soils, for people who are trying to achieve volume reduction goals, A soils can take that extra water, even if it's not necessarily being used for irrigation purposes. Again, I can go to the BMP Summary tab, and I will summarize the information here on that tab. Now, as I mentioned, I had meant to put this on A soils. I could go back and I could change that here, it did not affect my calculations. It's just basically for an accounting mechanism. If you're on the main screen here, you can go to the results section, and this will provide you information. So it's telling me that my routing is not quite right. Calculations are fine, but the routing, I might want to go back and take a look at that. I can still look at this, and it's still showing that I have 10 acres on B soils when I'm in fact using A soils. But this sheet here, this tab here will provide us information for the entire site. So if I had other best management practices, they would show up in this tab, and it shows performance summary, annual volume reductions, phosphorus reductions, dissolved phosphorus, TSS, and so forth. And it shows the schematic here. If I go back to my BMP, you'll see that there are links in here, or the help button here. Either one of these will take you into the Minnesota Stormwater Manual. I'll click on the help button here. It takes you to the page specific to that best management practice. In this case, it's requirements, recommendations, and information for using the harvest and reuse cistern as a BMP in the MIDS calculator. This page here, if I hover over page contents, will describe the methodology that was used for volume reduction and pollutant reduction. It will provide information on the routing for this BMP, some assumptions, and it will give examples. We have examples for both a cistern and for a pond in here, and then some additional information, links, and so forth. So in this module, we talked about the harvest and reuse best management practice. If you want to see other modules, you can go to these links here or type this link into your browser, and that ends Module 13.